So today we're talking about congruent triangles. And I'm going to show you a couple different ways that we kind of deal with congruent triangles. Now, the first thing that we're going to talk about, I'm going to use Roman numerals here. So Roman numeral 1 is what we call a congruency statement. And a lot of times, whatever problem that you have or situation or whatever it is going to start with a congruency statement. And that congruency statement is going to be this. Triangle ABC is congruent to triangle like DEF. So this is the congruency statement. When you say shape 1 is congruent to shape 2, whenever someone asks you for that congruency statement, that is what they're asking for. Now, the important thing is, everything that congruent triangles have to deal with has to deal with corresponding parts. So we'll talk about corresponding parts of congruent triangles. So I'm going to get this. So we have two triangles that are congruent to each other because I'm going to use the same mold for each one. And I'm going to say this is A, this is B, and this is C, this is D, this is E, and this is F. Now, the new definition of congruent triangles that has come out with the Common Core says that if I'm able to take this triangle and move it, I can put that triangle right on top of this triangle and they would be the same exact shape and the same exact size. You will see no difference between the two of them. And that's what it means to be congruent. And so congruency, if we say something's congruent, we get same shape and we get same size. Eventually, as you guys are filling that in, we're going to eliminate the equal sign from it. And we're only going to deal with that little squiggly up on top, the tilde, I guess you say in Spanish. And that's going to mean that shapes are similar to each other. Well, similarity in mathematics is absolutely, a huge important concept that you will revisit in every mathematics class that you have. And that means same shape, different size. And if you want to think about how important it is, think of blueprints, think of models, think of things like that where we make small versions of big things to make sure that we can make them right. So we always make them with scale factors. So like model cars are usually 1/16 the size of the real car. So if you multiplied all the dimensions by 16, you'd get the real size. But for right now, we're dealing with like a 1-to-1 idea here. However big this guy is the same thing. Now, everything is in the names. And we said that triangle ABC is congruent to triangle DEF. Now from here, what we're going to get 3 corresponding vertices, 3 corresponding congruent angles, and 3 corresponding congruent sides. I abbreviated because I was running out of room. But you got the audio with it, which is good. Now, take the name, ABC. Line it up. A, B, C. How do you think we're going to line up the second triangle? If I say A is going to correspond to a point, what point do you think it's going to correspond to? What makes logical sense? If I start with A, which one, D, E, or F? D. They both are in the first position of the name. And that is a huge idea, that the name tells you what parts are corresponding. So B is going to correspond to which part? E, and C is going to correspond to F. Okie doke. Now, the angles, we can just take this idea right here, move it right over, and say angle A is congruent to angle... What angle do you think angle A is congruent to? This angle up top here. D. Angle D. And remember, everything makes logical sense. And pardon my reach, but when we know that 2 angles are congruent to each other, we put these marks in there. Do you know what those marks mean? It means they're congruent. And that means their measures are the same. This means also that the measure of angle A is equal to the measure of angle D. They go hand in hand. And when we get a little bit more formal and start writing proofs and things like that, we need to be able to go from here to here, or from equal to congruent, and congruent to equal measures. Now, angle B is congruent to which angle? E, angle E, because B is corresponding to E. And now, I'm going to put 2 arcs there and 2 arcs here. Because I don't know if B and A are the same, so I can't put just 1 arc at B and 1 arc at E, because that'll tell me that A and B, D and E, those 3 angles or those 4 angles are the same. So I just put 2 separate ones. They might be equal to each other. We don't know. They could be. We don't know. Now, what's the third pair? Angle C is congruent to angle F. Remember, use that proper terminology. And in the picture, I'm going to put 3 marks at C and 3 marks at F. So when we're talking about corresponding parts inside the triangle, and we're talking about angles, you're going to see these congruency, what we call congruency arcs. And every time you see 1 arc, all those angles have the same value. So if I know this is 30, this is 30. And if I had another triangle in the same problem with 1 arc, that would be 30. Remember, they're all contained into the same problem. You can't transfer one from one problem to the next, but in the same problem, they're all good. Now, a cool thing that you can do for your triangles and for the sides are you can take the names and you can underline the first 2 and you get AB and DE. So you can say that AB, segment AB or side AB, is congruent to side DE. Which also leads me to say that the length of AB is equal to the length of DE. Now, would it make sense that from A to B that is the same distance from D to E in that triangle? That's the side between one arc and two arcs, one arc and two arcs. Lines up nice and neat. Well, I'm going to be a little bit weird, and I'm going to put 3 marks right there and 3 marks right there. Why do you think I put 3 marks there and 3 marks there instead of putting 1 mark and 1 mark, since it's my first group? It's opposite the angle with 3 marks. Now, what would be another side? You could go over to here and say BC and EF. So I can say side BC, segment BC is congruent to segment EF, which leads me to say that the length of BC is equal to the length of EF. So how many arcs is the angle opposite of BC? 1. So I'll put 1 mark here and 1 mark there. And that's just to keep things consistent. That's all. And so what do you think the last segment is? AC, the first and the last letter. Segment AC is congruent to segment what? DF, which means that AC is equal to the length of DF. And I get that situation there. So if I kind of zoom out here a little bit so we can see the whole big picture. This is your friend, CPCTC. Corresponding parts of congruent triangles are congruent. When we do proofwriting, as soon as we find out, that's the nice thing, as soon as we find out that the triangles are congruent, then we know all their corresponding parts are congruent as well. And here's the CPCTC. That's where it comes from. Corresponding parts of congruent triangles are congruent. So that's kind of an overview of what corresponding triangles are. What we're going to do with it is we're going to kind of take this one step farther and kind of take a look at some examples.